Hello everybody, this is Sudha Jamthe from USA from Stanford Continuing Studies. I'm going to talk to you today about the business junction of Internet of Things and artificial intelligence. I'm the author of 3 IoT books that you see here on stage on the screen, and I teach IoT business at Stanford Continuing Studies. So when I say business junction of IoT and AI, there's a term for it. It's called Cognitive Iot. So before we get deeper into the business side of things, let us get to the same starting point of what do I mean by AI technologies. So there's machine learning, supervised, unsupervised, deep learning, reinforced learning. There's all kinds of things that you do with robots in their motion and manipulation, computer vision, teaching them social behavior, natural language processing. It could be drones, it could be chatbots. So we can see a bunch of those in our examples. But all that comes under the bucket of AI. So when I say IoT and AI, it is a smart thing which is going to incorporate any of these technologies in its data and do something amazing. Now let us see what is the business impact. This is my worldview of how I have separated that out, saying machine learning is a big part. All the different technologies you see are different applications of facial recognition or voice to speech, speech to text, and then there is virtual reality or augmented reality. And primarily I'll be focusing on examples in terms of robots, drones, algorithms, and chatbots. So what is the business impact? This is a very nice summary put together by Shiva Angelis. I want you to look at the rethinking industry in here in the center. So look at so many industries. Agriculture, there's precision agriculture. Oil and gas does augmented reality. And manufacturing does Industry 4.0. Medical, there is so much machine learning stuff that's saving lives. Finance, it's FINTECH. Retail with so much beacons, they're collecting more data. What kind of more things can they do when they apply the AI aspect to it? So for us to have a conversation on this, I've actually grouped this into multiple different categories based on different kind of machine learning applications that they cater to. So the first one is social robots. The name is obvious that the robots interact with humans. So they interact on the home, or they're teaching kids something, or they're helpers in the airport doing customer service. The one at the top is actually looks like a lot of robots. It's a lot of them. They do noodle cutting. And so the industry they're impacting is healthcare, any kind of hospitality industry, education, and customer service in general. And the challenge here is natural language processing and learning social nuances. Then the second category I put together is called industry, where you see the distribution done by Kiva. These robots go and find out the items that needs to be shipped immediately, or they help in actual manufacturing. In BMW, the picture you see there, they're actually making the cars. Those are robots, right? And Jordan does waste management, sorting through things that should not be touched by humans in a hospital setting. And then the one at the bottom is security robots, and they help cops augment their work as extra helpers, but walking around looking at malls. So this again, caters to healthcare, manufacturing, supply chain, bunch of industries. Chatbots, I must have seen about 350 chatbots. Everything impacts healthcare, and their chatbots help impact healthcare too. The one on the right top you see is Melody from Baidu. Just so you know, chatbot is basically doesn't have a device, it doesn't have a form, it's more of algorithm. And I just put a picture to make that point. And Melody is a doctor's helper, it's a medical bot. There's tons of travel bots, and Amy is my most favorite one from X.AI, which is my scheduling assistant. So if you want to get time on my calendar, you email me, and Amy will help you find time. The one at the bottom is a nanobot, which is actually a device, but very, very, very tiny, and it helps kill pathogens and cancer cells. So the next category is deep learning algorithms. I separated out the chatbots from deep learning algorithms because though chatbots are algorithms, they are they are not doing major deep learning activity. They are doing machine learning in terms of natural language processing. That is the extent to which they are at least being applied today. And then they learn from the business use case they're trying to solve. Deep learning takes it a different degree, where it goes beyond machine learning, where you don't need to say what the factors are in the data and help the computer see patterns to figure out, like in the example of DeepMind from Google, it can look at pattern of data and predict kidney problems. Or this mind controlled robotic arm. Both are healthcare examples that I've given here. A third one also healthcare comes to mind is from Watson IoT, where a bunch of universities and hospitals are collaborating, looking at lots and lots of past customer data to look at patterns to come up with diseases and predict, not just like kidney problem, but for cancer research. And they actually have successful use cases where they were able to save life. My favorite one, and also the one that makes money, is drones. I've given you 4 examples here. The hydroswarm at the bottom here is from MIT, and a swarm is where a drone communicates with other drones. So they go around as if they are in a pod, like in a real setting, right? And then they do delivery, transportation. The one Matternet does delivery of items in a rugged terrain. Zipline does medical delivery of medical supplies in Rwanda. And the funny looking name, Of Course I Love You, is a drone from SpaceX which floats around in sea, and it captures the Dragon, the spaceship, as it comes back. And there is actually a financial value that has been estimated as, what we can get from drones as a service, that PwC has put together as a report recently. It's called Drone as a Service report, and you can see what we were talking about. Drones are doing surveillance, and mining, and all those industries are impacted. That is the infrastructure piece. Agriculture, they could do crop dusting. Transportation, we spoke about the 2 examples from Zipline and Matternet. Whole bunch of industries are impacted, but the important message here is $127 billion by 2020. That is the same time Gartner had said that we will have 50 billion devices. So it's kind of aligned on the same thing, but a drone is an intelligent cognitive IoT. I separated the drone from autonomous vehicles because I'm talking about vehicles on the like cars on the road, cars, trucks, right? Self-driving car is one, and there's so many different self-driving cars. There's a self-driving taxi in Singapore, and platooning trucks, which are like the swarms. They follow each other, and it's in Europe, and they actually go on a fixed path, and it can be used in mining, shipping, logistics, whole bunch of industries. They've been piloting and testing that out in Europe across, just getting the platooning trucks to drive around across multiple cities, not just in a limited mining setup. Then Civil Maps is the startup from MIT, which makes 3D vision computer maps, and those are much needed for any kind of autonomous vehicles. The final one I want to share is called mixed reality. Remember when we looked at what the worldview of AI from my perspective is, and I said there is AR and there is VR, augmented reality and virtual reality. There is a new jargon that's evolving called mixed reality, which is basically giving this AR or VR experience on top of our real lives. So the example of that is in a theme park. You're going on a ride and you would be wearing these glasses, and it would give you an augmented experience where this monster comes in and it tries to break the ride, and there's more panic and there's more thrill that sets in from that experience. There's a startup called VR Coasters that is doing that. Movies are all trying to do that, to create a mixed reality experience, and robotic surgery is done with augmented reality. And the one at the bottom is Yumu. It is from ABB. It's an industrial arm, and it is something where the arm is just not working on its own, but it's working, augmenting in a mixed reality setting along with the person who's also working on it. So I already said that Konica Minolta has created a augmented reality operating system, and they do an amazing stuff with oil and gas industry. So all this brings us to, where is the business challenge? We've been talking about the business opportunity so far. And business challenges, everything is machine learning or deep learning to some extent. So the example I wanted to share here, the two pictures are both for self-driving car. The one at the top is Belgian traffic data, and this is how you do the machine learning to understand the traffic signs. And the one at the bottom is from Udacity. It's an online site which teaches self-driving. It gives like a self-driving nano degree. It's global. You can check it out. And as part of the first exercise, they put this out, and I think it's a tweet from one of the instructors, Oliver Cameron. He basically said the self-driving car needs to figure out what are the lanes in the road and how does it so that it can stay within the lane. So that's the picture, and that does that by computer vision and machine learning. So in all machine learning, the big challenge is we need to build out data without biases. And there's tons of tribal knowledge, functional knowledge for different industry that needs to be translated well and captured into data. And then there's a lot of compliance on customer data across different industries like healthcare. And if you teach the robot to be social, there's a lot of social nuances. And the final thing is when you do voice to speech, there's different accents from different people. So it has to keep learning and it has to do continuous learning. So when you're looking at it from a business perspective, we'll have to look at the data governance. What kind of data, who has access to it, and how is it saved? What about privacy concerns? And the other thing is not much talked about, what I call as algorithmic accuracy. So all of these machine learning and deep learning algorithms are giving you a decision based on a certain degree of statistical confidence. So if it says 45% confident, can I go on a robotic surgery? Or if it says 57% confident that we can turn left, or I need to stop at a red light, can I let the self-driving car out into the street? So what amount of accuracy is right for your industry? What kind of accuracy is right for you to productionize and say now the product is ready, this smart IoT is now ready for prime time for a production pilot? So those are the things you'll have to ask, otherwise it will create business risk. So with that, I'm done. So there's a lot of opportunities, especially the drone business is $127 billion, but also we'll have to look at the business risk from data governance and algorithmic accuracy. So with that, I thank you for this opportunity. And my slides are here on slideshare.com/Sujamthe. You can sign up on Machine Bots. It's my YouTube channel where I do interviews with intelligent machines. Or for case studies, it's iotdisruptions.com. I hope you will tweet me and tell me what you think, what you're working on. Do you have passion in a similar area? I would love to hear from you. Thank you so much and have a good one.